Okay, in this particular segment we're going to cover tuning the instrument and checking the tune of the instrument. So the main thing we wish to do at this point is to make sure that the system is configured in the manner that we need. And it is. If it were configured with the LCMS spec, we would want to change the configuration to the mass spec with the syringe pump. The syringe pump is used to introduce the PPG or polypropylene glycol solution, which is the tuning solution into the instrument. And as we can see, that is the selected profile at the moment.
Don't forget to change your project.
Okay. The project in this case should be the API instrument. At this point, let's set up the hardware to match the hardware configuration that we selected. Right now, the instrument is configured for the LCF effluent to go into the mass spectrometer. We will disconnect that. And this is the syringe with the PEEK tubing that we will put into the sampler here. And connect the tubing to the source. Okay, in the tune mode, we're going to go to the manual tuning. And as you can see, this little icon here which says reserve instrument for tuning automatically is enabled. First thing that we want to do is bring up an example file, or open a file called Q1 positive PPG. Now, because we have two scanning quadrupoles, we have to tune both the Q1 and the Q3. So let's start with the Q1. We do not want to save anything at the moment. And as you can see, it automatically brings up the start and stop AMUs for looking at the tune ions that are produced. Here, right at this part right here, we can take a look at the syringe pump method, and it's set for 10 microliters per minute. Let's bump that up momentarily to 50 microliters per minute, just to get the sample, make sure that the PPG solution is flowing into the system. After a few seconds of that, we'll change it back to its 10 as the 10 microliters per minute. Set the flow rate. So right now it's flowing at 10 microliters per minute. We can either acquire the data or start the data. Acquire, I believe, saves the data. Start merely shows you, and that's what we're going to use at the moment. And it does take a second. There we go. So we can see the chromatographic tracing here, or the total ion tracing here, and over here we can see the individual ions, or the fragment ions that are produced. This gathers a set to gather, I believe it's 10 scans. It adds one scan to the other, and when this is finished, we can take a look at a report to see whether or not it passes the criteria that we set for acceptance. Okay, so if we right-click here, open file, we can see the individual ions, and if we right-click again, we can also make a list of the data and look at the calibration peak list. Let's take a look at this list, which is the most important. Okay, according to the manufacturer, the mass shift, or the deviation from the desired or the target mass, should not be more than 0.2 AMU. And as you can see, everything here is well within that range. The peak width should be between 0.6 and 0.8. And we can see that we have a failure here at the 1255 AMU. The intensity, the manufacturer has some recommendations, but at the GBI crime laboratory, the prominent ion that we look at, the primary ion, is the 906.6. This intensity we designate should be at least 8 e to the 6th, and we're certainly within that range. Because we had this one failure here, which is slightly over or outside the range of 0.6 to 0.8, the thing that we probably want to do now is to restart it and do it again and see if it passes the second time. Lisa, this has expanded so much. How do I get back to where I was?
I think that if you just click the X up there, that should take care of it for you.
Let's click on Start again.
Now that total ion chromatogram pane is
Here.
good to use, so you can tell that you have a nice, steady, stable signal throughout the time it's collecting the scans.
Correct. If this signal were to drop down to 0 and come back up again, that would usually be indicative that there's an air bubble in the line. And because it's doing an additive counts, that particular run I would never attempt to use it. And again, this total ion chromatogram looks pretty, or total ion count looks pretty stable across the 10 scans. We'll right click again, open file, right click again, list data, and let's take a look at the chart again. I'll click on calibration peak list. So the mass shifts here are all within within 0.2 or less. The widths, again, this ion failed. So this does not change the calibration tables whatsoever. All we're doing here is merely checking the calibration of the instrument. So as far as I'm concerned here, Q1 has failed. Let's take a look at Q3. So in order to check the calibration of Q3, we need to bring up the Q3 positive PPG file. We do not want to save that other. Let's see, has it come up? Yes, it has, because here we see it's set for Q3. So again, the syringe pump is still running. And another important note on that is it runs, so long as you're in selecting the tune mode here, the syringe pump runs until you tell it to shut off. So let's go ahead and start the Q3 calibration check. Okay, it started. We can see from right here, it's on scan 5, 6, and so on. Okay, we right click here, open file, right click again, list data, peak calibration list, and expand that where we can see it. This is certainly less than 0.2. And here it looks like 616 has not passed. So at this point, if this test here had passed, we would be performing a resolution optimization only on Q1, but since they both failed, we need to perform a resolution optimization on Q1 and on Q3. So let's click on resolution optimization. And the standard selected is PPG positive. This, we're going to do Q1 and Q3. Does everything else look right there, Lisa?
I think so.
Okay, we'll click on Start. This is an automated, this is an automated, lost for a word here, process. This is an automated process. And again, this takes roughly 2 or 3 minutes.
Mm-hmm. So the one thing we don't have to change when we do this is there's no place for it to ask you what speed you want the syringe pump to be running. So whatever speed the syringe pump was running in the manual tune check mode is the speed it's going to use for the resolution optimization.
Good point.
So normally we do this function at 10 microliters per minute because that's the same speed we use it in the checks. And it's going to perform for Q1 and Q3 a series of what it calls iterations, where it evaluates the PPG tuning solution and then checks it against the parameters to determine if it's acceptable, and it alters the calibration table results accordingly. So while we're running this function, it's going to update the calibration tables in the software. Isn't that right?
Yes.
Okay. Don't want to misspeak. Don't want anybody to be confused. So you can tell this is about the third time it's done Q1, so now it's moved on to the Q3 mode.
Okay, at this point the resolution optimization is complete, so we'll click OK. And it asks if we want to save the results of the resolution optimization. The answer to that is yes. And the report, the entire report, is here. And typically we save this report because it shows the tables and what was changed. Okay, so at this point we need to go back and just double check by doing another manual tune.
Well, I think we need to open the file.
Yeah, you're right. Because it was changed, let's go ahead and open the file. Q1 positive PPG. And as you can see, the syringe pump is still running. So and we're on Q1, so let's do another scan of Q1. Again, it will collect the results of 10 scans. Right-click Open File, right-click List Data. So in checking both the mass assignment, the peak width, and the intensities, the mass assignment are all within 0.2. The peak widths should be from 0.6 to 0.8. They are now within that acceptance criteria. And the 907 here is at least 8 e to the 6 or higher, and that is the case. So this has passed the criteria for acceptance. Let's then do Q3. We're going to open up the Q3 file. And start a scan with Q3.
Now you can also tell that the syringe pump is still running because of the icon on the bottom of the screen.
Yes.
The one that looks like
right
a
here
little
where it says
syringe,
run.
It says run.
Okay, again, right-click Open File, right-click List Data. This again should be with plus or minus 0.2, and it is. Peak width should be between 0.6 and 0.8, and the 907 has not passed that, and the 1255 has not passed.
Neither does the 1545.
Yeah. And because the resolution optimization spent a lot of time with Q3, from my practical experience has been that if we do another resolution optimization, that may be in order. However, just this time on Q3. So we'll click off the Q1 here and start the process again.
So this is going to be the exact same process that we did before. It's going to go through a series of iterations and evaluate it versus the updated mass calibration table. Apparently it only did one iteration this time.
It only does one, it thinks it's right.
Okay, complete. We need to save that. And again, normally we would print this and file it. We go to Manual Tune. Open Q1
Well, we could just do the Q3 this time,
I'm
right?
sorry,
Because
Q3
we only
PPG.
updated the Q3.
And again, start the process again.
Now, after you've performed some resolution optimizations, if it's still not behaving correctly, you may want to do some maintenance. If you haven't cleaned the curtain plate, you may want to go ahead and clean it or clean it again. You may want to clean the Q0.
Again, we still have the problem here. So at this point, I would recommend that maintenance is in order. But if the tune were successful, then we would proceed to injection of a test mixture to
Which is our
test the
next-
integrity of the entire system.
And setting up a batch is our next section to cover.